This demo shows how the FAST scheduling system by Unique Scheduling Solutions handles not only the simplest scheduling problems, but also how it captures problems with increasing complexity. By starting simple, we can show the basic operations of the system, and by doing that, provide a good guide for getting started. So if you're looking for a scheduling system with for a very challenging environment, stay with us, because as the demo progresses, we'll show you a lot of capability that will apply to virtually any scheduling environment, no matter how complex it is. When you become a user, we create what we call a site for you. In this demo, the site is called Acme Manufacturing. Within your site, you can have several different domains, and within each domain, you can have as many timelines as you need. For this demo, assume you're a company with several offices. We've created a domain called Springfield Office and a timeline called Meeting Schedule. So let's start with a very simple resource booking problem. We'll schedule a meeting into a conference room. We've made the conference room available for March 16th from 8 a.m. to 5 p.m. Now we'll define an activity called Project Kickoff Meeting, and it will have a duration of, say, 2 hours and a requirement for the conference room. Once the activity is defined, we can schedule it immediately by clicking the Schedule button. Notice that the activity now appears on the scheduled list, and the conference room is now booked. But let's assume now that you didn't want to schedule a meeting at 8 a.m. Instead, you wanted to schedule it at 9:30. Let's unschedule the meeting and go back to the activity editor and look at the Possibilities button. This shows that we could schedule this activity starting any time between 8 a.m. and 3 p.m. as expected. To schedule a meeting at 9:30, we simply specify that start time. So that's really all there is to it. All there is to using the FAST system as a simple resource booking system. Next, we'll look at scheduling more than one activity at a time. We've created a second activity called Senior Staff Meeting with a duration of 93 minutes and a requirement for the conference room. And we realize that meetings are not usually scheduled down to the odd minute, but we did this to illustrate that the FAST system does not assume any preset intervals for durations or any other time references. That is, there are no buckets like 15-minute intervals, 1-hour intervals, or 1-day intervals. To schedule multiple activities, you simply select the ones you want to schedule and click the Schedule button. Notice that we now have the 93-minute activity scheduled. Of course, we could have defined many activities and scheduled several at the same time. So the system works both as a manual scheduler and a batch scheduling system. We should note here that the FAST application is domain independent. That is, it uses resources and activities that you can name to be anything you want. So if this illustration doesn't include your terminology, we hope you can see that the system applies to all domains and that it's easy to make your system look like it was developed especially for you. To show this, here we have a data set where the activities were surgical operations in a hospital and the resources were operating rooms and physicians. Notice that the activities here are called cases and the resources are operating rooms, physicians, medical equipment, and so forth. This system looks like it was built especially for a hospital. This particular example has 150 activities and 80 different resources. returning to our simple example, we've already mentioned that the senior staff meeting has a duration of 93 minutes, illustrating that there are no preset intervals, such as 15-minute intervals, 30-minute intervals, and so forth. This bucket list time feature is important in many environments where packing the timeline is necessary for accurate modeling of the capacity. Unlike many schedulers and spreadsheets, FAST does not use time buckets. Instead, it treats time as a continuous variable. Now let's postulate that the senior staff meeting also requires a laptop. We've added two laptops called Laptop A and Laptop B. They're available between 8 a.m. and 5 p.m. We've also specified that the senior staff meeting requires a laptop, but here we've said that any laptop will do. That's what we call a wildcard resource requirement. Unlike other systems, the FAST system will find all combination of wildcard resources and select the combination that contributes best to the scheduling objective. So let's reschedule both activities. The system selected Laptop A. Now to add a little generality, let's assume that the laptop is not required until 45 minutes into the meeting. We can simply change the requirement to show this offset. So let's look at the resource profile. That shows the offset as well. Most scheduling systems assume that all resources are used for the entire duration of the activity. The FAST system does not have this limitation. We can specify as many on and off intervals within the activity as you want. This again supports a much more accurate description of the capacity of whatever environment you're trying to schedule. Now let's create a slightly bigger scheduling situation. We've added two more activities and another room. We've added a resource called Boardroom and an activity called Proposal Preparation with a duration of 5 hours and 10 minutes, and another activity called Project 42 Monthly Status with a duration of 75 minutes. We'll use wildcard requirements for the rooms needed by all these activities. If we look at the senior staff meeting, we can go to the Possibilities button, which is a unique feature of our scheduler. This shows all the possible combinations of resources and start times when the activity can be scheduled. The user can pick any one of these possibilities and schedule the activity manually, or let the scheduling algorithm, called a solver, pick the best possibility. If we use the tightly packed solver to schedule these activities, we see that the boardroom is used as much as possible. If we unschedule everything and go back and use the other solver, which is the fair share solver, you can see that the algorithm distributes the assignments for the rooms as evenly as possible. We've used the fair share solver to schedule a tennis league where we were trying to give each player about the same number of matches with different opponents. We've already implemented a way for you to build your own solver, but we'll show this in a different demonstration. Now let's say there are people who must be in these meetings, and some of them have to be in more than one meeting. We've added Joe Jones, who is VP of Operations, and we assume that he needs to be part of the senior staff meeting and the proposal preparation meeting, but he isn't needed for the entire duration of either meeting. Let's assume he's needed for the first 10 minutes and the last 15 minutes of the proposal preparation meeting, and is needed for the first hour of the senior staff meeting. Let's reschedule now and see the assignments for Mr. Jones. Notice that Mr. Jones is assigned to the proposal preparation meeting from 8 to 8:15. From 11:15 to 12:15, he's in the senior staff meeting for an hour. Then he's back to the proposal preparation meeting from 12:55 to 1:10. Now let's look at how we handle pooled resources. These are resources that are available in quantities greater than one. Let's assume that all these meetings require chairs, and let's assume that there are 20 chairs available. The initial availability can also be a function of time, but to keep it simple, we'll just assume a constraint of 20 chairs available at all times. We'll also add the requirements for chairs to each of the meetings. Now let's reschedule with the chair requirements added. Notice that the constraint on chairs has precluded all activities from being scheduled. We know that chairs shouldn't constrain the schedule because we can certainly find additional ones. Let's see how many we may need. To do this, we'll use another unique feature of the system. We'll switch the chair requirements from being strictly enforced to being tracked. The system will allow violations of the constraint, but show exactly how big this violation is. When we reschedule with this change, we notice that the activities schedule as expected. So let's see how many chairs we really needed. This graphic shows that we need 27 chairs and we have available 20. It shows exactly when we need those chairs. The track feature is very key to using FAST for capacity planning. If you anticipate you might need additional resources by using the track mode, you can see immediately what resources are needed, how many are needed, and exactly when they're needed. Now let's assume one additional constraint. Let's assume that the senior staff meeting must be concluded before the Project 42 monthly status meeting starts. Let's even say that there must be a 20-minute gap between the end of one and the start of the other. We'll specify this predecessor and offset relationship between the two activities by adding the predecessor and the offset to the Project 42 monthly status activity. Now let's reschedule. Notice that the two meetings are separated by the 20 minutes, one ending at 9:33, the next one starting at 9:53. An activity can have as many predecessors as desired. This allows an entire precedence network to be specified. These networks occur frequently in project scheduling situations. The FAST system will enforce the predecessor constraints and even integrate the predecessor and priority specifications to the degree possible. We hope this demonstration has illustrated several important points. That the simplest problems are also simple using FAST. That as the complexity of your scheduling environment increases, the capabilities of the FAST system can accommodate your needs. That whether your domain is manufacturing, healthcare, hospitality, transportation, education, sports, or any other domain, the FAST system is a good fit.